All right, so we are going to continue talking about circles. Today we're talking about a different part of circles. Last time we focused on angles inside the circle. Today we're going to focus on the lines that go from one side of the circle to the other and all the different relationships that come from those lines. So remember, a line that goes from one side of a circle to another is what we call a chord. Okay, that's the word that we use to name those lines. Now, the first relationship that we have, this first box up here on the left says that if two chords are congruent, then the arcs are congruent. So what that is saying is if this chord, this red chord, is congruent to this red chord, let me get my colors that are going to stay. If this red chord is congruent to this blue chord, then their arcs are also congruent. Doesn't matter where on the circle they are, if the chords are the same length, then the arcs that go with them are also the same, not the same length as the chord, but they're the same length as each other. Notice on the diagram that if this chord is equal to this chord, then this arc is equal to this arc. Okay? Relationship number 2. Over here on the right, if a diameter of a circle is perpendicular to a chord. So you've got the diameter right here in blue, and it's perpendicular to this chord. What that tells you is that the diameter is going to cut the chord in half, and it's going to cut the arc in half. So if this is a 90-degree angle, then this chord right here, this big long green one gets cut in half, so you get this piece equals this piece, and the arc also gets cut in half. So this arc is equal to this arc. We're going to use that in some of the math that we do later. Relationship number 3. Sorry, my pancreas is needy. Relationship number 3 says if two chords intersect in a circle, so in my picture, I've got, where's my highlighter? I've got this yellow chord, and it's going to intersect with this red chord. So if two chords intersect, then the angle at the intersection. So it's talking about this angle. Let me zoom in a little bit here, and I'll switch my pen. This angle where they intersect happens to match this angle, right? We know that rule because they're vertical angles. Those two angles are an average of the two arcs that are connected to those angles. So lots of stuff going on here, but notice this intersection, you end up with two arcs, well, 4 arcs. You've got this angle that makes arc A, and then you've got this angle that makes arc B. Well, the measurement of these inside angles is the average of arc A and arc B. So if you add those two arcs together and divide by 2, that's going to give you the measurement of this angle on the inside. Now, the same thing happens if I were to measure this arc. If I called this C and I measured this arc and I called it D, then these angles on the inside, these other two angles, would equal C plus D divided by 2. So you can add those together, divide by 2 to figure out the arc length. And then the last one says that if two chords intersect, then the product of the parts of 1 equals the product of the parts of 2. This is also pretty cool. So I've got two chords that intersect. This one is broken up into A and B. The other one is broken up into two parts, D and C. So what this rule tells us is that if I multiply the parts, A times B, that's going to equal C times D. That relationship is going to be equal when you cut the parts into the chords into two parts. All right, so let's use all of that mumbo jumbo and try to do some math problems. So example number 1, or example A, it looks like I've got an inscribed angle. I've got two chords, and it tells me that they're the same length. So I've got this yellow chord right here that's the same length as this yellow chord. And it wants me to find x and y. So first of all, I'm going to start with x. So if I want this arc, I can go back to the last video where we learned that an inscribed angle is half of the arc. So if that angle is 42 degrees, that means x is 84 degrees. That arc on the outside is 84 degrees. Well, that got me x. Now I've got to find y. Well, I've got two chords that are the same length, so that means that the arcs that go with them, this arc right here and this arc right here, are the same length. So this is also length y. And when I try to figure out what y is, I know that a circle is 360 degrees. And that yellow arc is already 84 degrees. So I'm going to minus 84, and I'm going to get what? If I minus 80, I get down to 280, but I got a minus 84, so I get 276. So those two green arcs add up to be 276 degrees, but because the chords are the same length, then these two arcs are the same length. So I can just take that 276, divide it by 2, and get what? 88 degrees. So 88 degrees is going to, that's not divided by 2. That's half of 176 degrees. Bad math, Mr. Reed. This is what happens when I don't look at the problems before. We need what? 138 degrees is what we're going to get when we cut that one in half. So y is equal to 138 degrees, and this angle, or this arc over here, is also 138 degrees. All right? Okay, example number B. We'll try to do a little bit better this time. I'm looking for x, and x is this angle that is created when this green arc intersects this red arc. And there's a rule right above me, right here, that says that the angle on the inside is equal to the average of the angles on the outside. So when I look at my picture, my outside arcs are 31 degrees and 153 degrees. So if I add those together, if I take 153 and I add 31, I get 184 degrees. Well, x is going to be half of that. It's going to be that divided by 2, right? So 184 divided by 2 is 92 degrees. So this angle is 92 degrees, which means this angle is also 92 degrees. Okay, part C. I've got a chord. This yellow chord right here is perpendicular to this chord, and it also happens to be the diameter. Now, when that happens up above, it tells us that this arc and this arc are the same length. So if this arc above is 33 degrees, then x is also 33 degrees. Now, if those two arcs are the same, I can defer to the fact that these two that are left over are also going to be the same, because we're taking an equal amount from each of those two sides. So this half of the circle is 180 degrees. So if I take 180 degrees and I minus 33 degrees, I end up with what? 147 degrees left over. So y is 147 degrees, and this part down here is also 147 degrees. Okay, D. I've got two chords. They are intersecting. And I've got one of the arc lengths, but not the other arc length. So I think I'm going to use this idea, but instead of finding the angle, I've got to find the arc lengths. So what that looks like, I know that if I take 95 and I add it to x, and then divide by 2, I'm going to get 87 degrees. That's what that rule says. If I take this arc and this arc, add them together, divide by 2, that gives me this angle right here. So 95 plus x divided by 2 equals 87. Then I got to do a little bit of railroad track stuff to get my x alone. So I'm going to multiply by 2, so 95 plus x equals what? 174 degrees. Yeah, that looks right. 174 degrees. Then I've got a minus 95 from this side. So 174 minus 90 is what? 84. But I got a minus 5 more, so that's going to be 79 degrees is equal to x. So this arc right here is 79 degrees. And 87 is in the middle. Okay? I guess the other way we could have done that is because I know that, and sometimes math is a little bit more fun to just common sense your way through. If 87 is the average, that means 87 is in the middle of 95 and whatever x is. So to go from 95 to 87, I go down 8, which means I would have to go down again 8 to get to x, which would give me 79 degrees. So either way, you get the same answer. All right, E. Excuse me. I've got 2 chords. Two chords, and they're intersecting each other, and then it's giving me lengths of the chords. So I think this one's going to use this last rule that we learned up above that says if I multiply the parts of the chords together, then they equal each other. So if I take, what that says is if I take 10 and multiply it by x, I get the same thing as if I get 16 times 5. Okay, so let's write that down. 10 multiplied by x is equal to 16 multiplied by 5. So that means 10x is equal to 80. And to get x alone, I just divide by 10. And 80 divided by 10 means that x is equal to 8. So this length right here would be 8. That's a cool rule when you're dealing with intersecting chords. Now, F looks like there's all sorts of stuff going on. I notice a diameter right here, and I notice that it is perpendicular to this chord. So that tells me that the arcs and the parts of the chord are cut in half. So if this is 8, then that means that this is 8 as well. And let's see. Now I've got a right triangle. This is taking us, this isn't even using all circle stuff. We've got to use Pythagorean theorem on this one because I've got this right triangle right here, and it tells me 2 of the sides. It tells me that one is 10, one is 8, and it wants me to find the other one. So if I do a little bit of algebra, I know that 8 squared plus x squared equals 10 squared. So 64 plus x squared equals 100. So x squared equals 36. So x equals 6. Right? I'm just doing railroad track, but I'm going kind of fast because we do this all the time. So that means that x, this length right here, is going to be the length 6. And what else does it want me to find? It wants me to find y, which is the other side of that diameter. I do know that I'm going to have to use a little bit of inference here. I know that x is now 6. And I also know, if I look at my picture right here, this radius right here from the center to the edge of the circle is always the same distance. So that distance, that blue distance right there is 10. This distance right here is the same distance. So that means that 6 plus y is equal to 10. So then I can just defer from there that y is equal to 4 because x was the 6. If I add them together, then I get 10. So that gives me my x and my y. So now you're on your own. Now you get to practice some problems that all look very different. I realize they don't look exactly like the examples above, and they're not supposed to. You need to take what you've learned about chords and arcs and other parts of circles from 6.1, and you need to apply that to help you find the missing parts. Colored pencils are going to help a lot, especially like if you look at number 5, there are so many different things going on in number 5 that it can get a little bit overwhelming. Like I see this 102 degrees is made up from, what is that 102 degrees? That's this arc right here, which isn't really an arc, but it's these two chords getting intersected. So if that's 102 degrees, that means this is 102 degrees, and I can use my, like that angle is the average of the two outside arcs. That can help me find x. But that's not going to help me find y. Y has something, all sorts of other stuff going on. When I look at y is this angle right here, which is connected to this arc. So I guess once I know x, maybe I can find y using the same rule, because y is going to be half of 25 plus x, since those are two other intersecting chords. So there's a lot of stuff going on in this picture. You've got this chord intersecting this chord, and then you've got that same chord intersecting this one, and then you've got this one also intersecting this one. So there's a lot of different things going on. Again, use colored pencils. They help a lot. Kind of just focus what you're looking at and help you make some connections without getting overwhelmed with all the other information in the circle, because there is a lot of stuff going on. All right, come see me when you need help.